Welcome to the fourth lecture. So in this lecture, we'll start looking at the object-oriented principles. We have already learned about the objects and classes. And there are four fundamental concepts of object-oriented programming. They are encapsulation, inheritance, abstraction, and polymorphism. Although not considered as core object-oriented programming concepts, cohesion and coupling are two important concepts that we have to know about. In this lecture, we will be talking about the two object-oriented principles called encapsulation and inheritance. So at the end of this lecture, you should be able to apply the two object-oriented principles, encapsulation and inheritance, in object-oriented programming development. The first one is the encapsulation, which may be the easiest to understand. So if you look at the word encapsulation, which comes from encapsulate, which again comes from capsulate, which again comes from capsule. So I hope you know what a capsule is. So when you get sick, sometimes you get a capsule to drink, like an amoxicillin. So you don't see what is inside. You just see the outer coating. So that is exactly what is meant by encapsulation. You hide what is inside and give an outer coating which hides what is inside. So all you see is the outer coating. The same concept is applied in programming. Here, what we hide or what is inside is the data. That means the variable. So attributes of an object. So if these attributes are provided to the other classes through the members, that means the methods of the class. So these methods that open up the attributes to the outside world, which we call the public interface. So again, to elaborate, for a given class, its attributes or the data members should be hidden, which we call data hiding, and they should be opened up or exposed through public methods. The set of public methods together we call the public interface. And don't get confused. There's no rule to say that all the methods have to be public. If you need, depending on your logic, some of your methods can be private. However, what we mean here is that if some method is part of the public interface, you should not hide that method, or you should not make that method private. So how are we going to hide our data and open up or expose our methods? It's very easy. All you have to do is to add the private keyword to the attributes and the public keyword to the methods that belong to the public interface. Now, this concept of encapsulation is not only specific to the object-oriented programming paradigm, but you can find it applicable in other programming paradigms as well. So in the context of object-oriented programming, what we do is we hide our attributes or the variables of the class and open them up. The whatever should be opened up, we open up through the public interface or our public methods. So the main benefit is it hides the complexity of your code. That means, for example, you may want to change the name of a variable. You may want to change the default value of a variable, or you may want to change the logic or the implementation of a method. However, as long as you have used this concept of encapsulation, none of these changes would affect the other classes that use this class. Why? Because they are hidden from the other classes. So as long as the method signature, you know what the method signature is, the access modifier, the return type, and the method name and the list of parameters. As long as these remain unchanged, you can do any other change to the your data members and to the method implementation. So this inherently reduces complexity. Why? Because you know, now you know that when you change one place, it will not have a ripple effect. That means it won't affect any other place. So it's easier to maintain code written in that way. And another thing is, if you look at this code, so now integer age is private, you cannot access it directly. You have to access it through the getter and setter, get name and set name. So if you want, you can add some additional logic that governs how this attribute is accessed. The other one is, if you want, depending on your logic or your requirements, you can make some fields as read only or write only. So as you can see, if an attribute has only a setter, it is write only, because we can only set the value but we can't read the value out. And if a method, if an attribute has only a getter associated, that it is, we say it is read only, because the value cannot be set through any method. So this functionality is achieved because the attributes are now hidden and they are opened up through these getters and setters, as well as, of course, other methods. The next most important object-oriented principle is inheritance. The other two principles, abstraction and polymorphism, depend on the concept of inheritance. To understand the importance of inheritance, let's look at this code. So here we say the code written for the monster class. So here it has int age and string name and some getters and setters. If you go to the warrior class, so it also has the int age, int name and similar getters and setters for age and name. So that means the same code has been written in two classes, which we call the redundant code. The problem is called code redundancy. So in order to remove that, we can make use of inheritance. In fact, the concept of inheritance is something that has been borrowed from the real world. For example, if you look at the birds, a duck or a cuckoo or ostrich, they are all birds. And if you look at the shapes, triangles, rectangles, they are all shapes. And similarly, bicycles, mountain bikes, road bikes, tandem bikes, they are all bicycles. Right? And if you take a person, a baseball player, an employee, everyone is a person. And you can have hierarchies as well. For example, if you take a rectangle, it can be a square or a rectangle, right? So, and again, if you take an employee, it can be a supervisor, it can be a junior laborer. Likewise, we can have hierarchies. So, what we see here is what you call an is a relationship. For example, we can say the duck is a bird, a cuckoo is a bird, and a triangle is a shape, an employee is a person. So, in essence, from inheritance, we achieve this, or we capture this is a relationship that is between the entities. So remember, in object-oriented programming, we talk about a set of interacting objects. So here, one form of interaction is captured, the is a relationship. That is kind of an interaction between objects. So the idea is our superclass. So here the bird is the superclass, and the shape is a superclass, and the person is a superclass. So these superclasses will capture the information common to the subclasses. So for the bird, we have the duck and cuckoo and ostrich as the subclasses. So what are the common properties of these subclasses? They have a beak, they have wings, they can walk, they can maybe fly, maybe not, because ostrich cannot fly. So as you can see, some properties are common. So just like what we saw here, the monster and the warrior having some common properties, here also our subclasses have some common properties. The idea of inheritance is we define a superclass that captures the common properties, and then we extend the superclass to the subclasses which may have some additional properties on top of these common properties. For example, this can walk thing. So if not, so you might know that some birds cannot walk. So some birds cannot fly. So in the bird superclass, we should not have any method corresponding to the fly. So the birds that can fly will have this additional method on top of the common bird property. So that is what we mean by extending a base class by a child class or a subclass. So this is what I explained using the diagrams a few minutes back. So inheritance allows child classes, that means subclasses or derived classes, to inherit the characteristics of the parent class. So look at the words. Sometimes the same word refers to the same thing, right? So child class, subclass, derived class. And similarly, parent class, base class, superclass. They all refer to the, there are multiple names to refer to the same concept. So when we say inherit, the child class or the subclass can inherit the superclass's attributes and operations both. So in that case, we say the child class extends the parent class. So extending can happen by adding new fields or new methods. So like here. So our bird class has the attributes wings and beak and can walk method. And then duck and cuckoo will add a new method on top of that. That is the fly method. So it was not in the main superclass. So that means the duck and cuckoo extend the bird. That means they get all the properties of the common superclass bird, and on top of that they extend. That means they have additional properties and methods. And sometimes subclasses can have properties or methods specific to them. For example, duck is the only bird who can quack. So the quack method will go to the duck class. So that is a method that, so duck extends the bird by adding a new method called quack. So as I described, inheritance builds an is-a relationship. You can't use it to make a has-a relationship. So normally has-a relationship exists between the object and attributes. For example, we can say dog has a name, but we can't say dog is a name. So always think when you use the relation is-a relationship, are these objects subclass, superclass? So for example, if you say then dog is a name, that's wrong. And you can't say name is a dog because name is not dog or dog is name is not name. However, we can say dog is an animal. So that is an is-a relationship. So always think carefully before using is-a relationships. So sometimes people make mistake, so they don't realize that is-a relationship has to be, they are only with related objects. So always, if you are using the extending parent class to a subclass, just see whether subclass is actually of a type parent class. So this inheritance is very extensively used property in Java API. So you might have already seen the Java class hierarchy. At the top, we have the object. All the classes in the Java API extend from the object. So as you can see, so if you look at the middle, from object, we have the number subclass. From the number subclass, we have the byte subclass. And if you look at the permission, so permission extends the object, and then basic permission extends permission, runtime permission extends permission, as you can see. So this subclass, superclass create a hierarchy of classes in Java. And at the very top, we have the object. So if you are using an IDE such as Eclipse or NetBeans, you would have noticed that when you are creating a class, automatically the superclass field is filled. What this means is, by default, every class that we create will have the object superclass. Now, I hope you all have used the method system.out.println. Did you ever write the code for the println? You just, as if by magic, you just use the println method. But in any of your classes, you will not define this println method. So where is this println method? If you go to the object, you will see that this println method is defined in the object class. So because our class always extends the object class, this public method is this method is inherited by the subclasses. It may be a protected, you will have to check. It will be protected or public. We'll have to double check. So, so as I told you, a subclass can inherit the attributes or the fields and the methods. So, if you look at the superclass, as long as the attributes have either the public or the protected keyword, the subclasses can inherit. So, with respect to attributes, if the superclass attribute has the keyword public or protected, the subclass can use them just like any other field in the subclass itself. And if the subclass wants, it can declare a field that has the same name as the superclass variable or attribute. So this is called the hiding the variable in the superclass, but it is not a very good practice. So don't try to use it. So there is no restriction that the subclass should restrict itself to the attributes in the superclass. It can always go and create new attributes. This in fact is what we mean by extending. The subclass will get whatever that has been defined in the superclass, but on top of that, it can go and define any other additional attributes that are specific to the subclass. Similarly, methods, as long as the methods are public or protected, the subclasses can just use them as if they have been defined in the subclass. And a subclass can have the same method signature just like in the superclass. So this idea is called method overriding. So although the variable hiding is not recommended, overriding is okay. In fact, in many instances, people use method overriding. So what is method overriding? In our superclass, we have a method, and in the subclass, we have a method with the same signature. So the implementation may be different, but the method signature is the same. In that case, we will say method overriding. However, if the superclass have a static method, the subclass may have the same static method signature as the superclass. In that case, we are hiding the superclass static method, which is not much of a good practice. And just like in the attributes, we can declare new methods in addition to the methods that we inherit from the superclass. So that is exactly what we mean by extending the class. So we have certain functionality in the superclass. We add additional attributes and methods in the subclass, meaning that now it has more functions than the superclass. So that is what we mean, the subclass extending the superclass. So when a subclass extends a superclass, we will have to call the constructor of the superclass. So if you don't add any explicit logic by using the super keyword, which you of course learn later, the Java runtime environment will implicitly call the default constructor in the superclass. But if you want, for example, if you want to pass parameters from the subclass to the superclass constructor, you can always use the super keyword, which we will be learning later. So here's the example of method overriding. So in the superclass dog, we have the bark method, and in the subclass hound, we have the exact same signature, public void bark. So this is called the overriding. And there's a similar concept, overloading. So overloading means within the same method, within the same class, we have two methods of the same name, but the method signatures are different, right? So in overloading, we consider it only for within one class. Within one class, we can have two methods with the same name, but the overall method signature is different. For example, in the first bark method, it takes no parameters. In the second bark method, it takes an integer number. So the left-hand side, when we have the same method signature in the superclass and subclass, we call overriding. In the overloading, within the same class, we have two methods, same name but different signatures. So now let's look at an example of using inheritance. Now this is the same example that we saw earlier. We have a monster class which has attribute age and name, and then we have a warrior class which has the same age and name attribute and some other attributes on top of that. So now we can apply the concept of inheritance here. So what we can do is, rather than having the age and name repeating in monster and warrior, we can create a new superclass, game inhabitant, which will capture the common attributes and methods for the warrior and monster. So here we have the int age and string name, and then we have the getters and setters for these attributes, and now we have the monster extend in the game inhabitant. So this is how we can extend a superclass by a subclass. We use the word, the keyword extend. So this is an example of using the super keyword. So now here we have the monster constructor, and from the monster constructor now we want to explicitly call the game inhabitant constructor. So we don't use the word game inhabitant, but we use the word super. So by default, when you call the super, the constructor of the game inhabitant constructor will be called. And similarly, now the warrior is extending from the game inhabitant. Now, in addition to the data and the attributes and methods that we get from the game inhabitant superclass, the warrior has some additional attributes. So this means the warrior extends the functionalities of the game inhabitant. Another important thing you have to remember is Java does not support multiple inheritance. So what is multiple inheritance? That means the ability to extend from multiple classes. If you try to add a new superclass and try to add it here, you will get an error. So Java supports only single inheritance. So we discussed how to achieve inheritance through subclass-superclass relationship. But there's another way to achieve inheritance, that is through interfaces. So to understand what these interfaces are and the need for interfaces, look at this example. So again, related to the Monster Warrior example in our game simulation. So the requirement says that warriors are of two different types, normal warriors and super warriors. Only normal warriors need to take a rest now and then. And super warriors can fight with monsters, but normal warriors cannot fight. So now, so we had the subclass-superclass relationship where monsters and warriors are game inhabitant. In other words, warrior is a game inhabitant and monster is a game inhabitant. So both warriors and monsters are extending from the game inhabitant. And now we see another subclass-superclass relationship here. Warrior has two subclasses, normal warrior and super warrior. So normal warriors need to take a rest now and then, and the super warriors don't have to take a rest. And super warriors can fight with the monsters. So that means who can fight? Super warriors can fight, monsters can fight, but not the normal warriors. So now we want to capture the fighting, the logic related to fighting that will go into the monsters and super warriors. Of course, now monsters will have, if in the basic case, we can add the logic separately to the monsters and separately to the super warriors. However, if the code is the same, if the fighting code is the same, again, we have the problem of code redundancy. However, now we cannot create a new superclass to capture the common properties of fighting for the super warriors and monsters, because monster is already extending the game inhabitant class. Now our super warrior will be extending the warrior class, and Java supports only single inheritance. So in that case, interfaces come into the help. So in other words, interfaces is a way of achieving multiple inheritance. So unlike extending a class, we can implement any number of interface. So interface just have the method signature. It says what method is supported by a class that implements this interface, but the actual interface will be or has to be provided by the class that implements this interface. So let's look at another example related to the previous one to understand this concept. As you can see here, in our earlier design, we decided that monster extends the game inhabited. So this is extending a class. So this is single inheritance. But now we want to capture the common fighting behavior for the monster and the super warrior. So what we do is we capture the fighting methods in the iFighter interface, and we get our monster to implement that iFighter interface. So in our iFighter, so I'll go to the iFighter interface first. So this is all that the iFighter interface has. As you can see, the iFighter interface just have the method signature. This we call an abstract method declaration. That means we don't have the implementation detail of the file method. We just have the declaration of the method. So when the warrior calls the iFighter method, it must implement this fight method that was in the iFighter method. Otherwise, you will get an error. So similar to the monster, now our warriors are two types: normal warrior, super warrior. Normal warrior just extends the warrior and it does not know how to fight, but a super warrior knows how to fight. So we want to implement the fighting logic. In order to do that, it just implements the iFighter interface, and this also must implement the logic for the fight method which has just been declared in the interface. So if you implement, if you say you are implementing an interface, as a rule, you must implement all the unimplemented method, or that means just the methods that have been declared in the interface. So this is the use of interfaces which achieve some kind of multiple inheritance. So here we show the terminology differences. So if you have a superclass, if a subclass extends it, we say the subclass or the derived class or the concrete class inherit the superclass or the base class or the parent class. Look at that, see that for the same concept we are using multiple terminologies: derived class, subclass, concrete class, or base class, parent class, superclass. And similarly, we say a class implements an interface. A class inherits another class. A class implements an interface. So a class cannot inherit an interface, and similarly, a class cannot implement another class. So get the terminology correct. And when you're coding, you have to use the appropriate keywords. For the subclass superclass relationship, use the inherit keyword, and implementation, if the class is implementing an interface, you have to use the implements keyword. However, an interface can extend another interface. So as you can see here, we have the super interface sports, which has two methods: set home team and set visiting team. And we have another interface, football, that extends the sports interface. So this football interface will have three new methods: home team scored, visiting team scored, end of quarter. And on top of that, it will receive the set home team and the set visiting team methods from the super interface. So keep in mind, an interface can extend another interface. A method can implement an interface. A class can extend another class. Get the terminology correct. So this inheritance is very important and very useful. So as I said, to implement the other two object-oriented principles, that means abstraction and polymorphism, we must start with inheritance. Inheritance must be there for that. And as we saw, the reusability of code, that means avoiding the redundant code and have code in one place that can be reused by other subclasses is a very good property. And also now in the monster and warrior class, if we want to add another game inhabitant, maybe some angel or something, so that angel can also extend the game inhabitant superclass. So we are extending the code by adding a subclass easily. We don't have to duplicate the code that is in the superclass. We just get the angel class to be a subclass of our game inhabitant superclass. And as I told you, the abstraction and polymorphism depends on the concept of inheritance, which we will be discussing in the next lecture. So in summary, in this lecture, we looked at the two object-oriented principles, encapsulation and inheritance. And in the next lecture, we look at the abstraction and polymorphism.